Alright guys, today we're talking about solving equations and inequalities with the variable on both sides of the equal sign. Okay, so the variable is going to be on both sides of the equal sign. Alright, so let's talk about what we need to do to be able to solve these suckers. So first step, okay, when I have a variable on both sides of the equal sign, you must move the variable to the other side to be able to combine like terms. So again, like terms are the same variable raised to the same power. Okay, so here's my first example. I've got 5x is equal to 2x minus 9. Again, we have an x over here and we have an x over here. Well, these are like terms, but in order to be able to combine those like terms, they have to be on the same side of the equal sign. So my job is to move one of them to get them on the same side. And again, when I move something in math, I need to do the inverse operation. Okay? Now, anytime that I'm moving something, I'm always going to choose the lesser of the two numbers. So in this instance, 5x and 2x, the lesser of the two numbers is this 2x. So that's what I'm going to choose to move. Now, it does not matter. You could move the 5x to this side and you'll get the same exact answer. Okay, but it's just easier for me to move the smaller number because you're not dealing with negatives. Okay, so again, I move this 2x, and again, how you move something in math is you're going to do the inverse operation. Right now you have 2x, so it's a positive 2x. When you move it, you need to subtract 2x to both sides. 5x minus 2x, I can combine those because those are like terms, and that gives me 3x. Over here you're left with a negative 9, so 3x equals negative 9. The last step, this is 3 times x. So the last step is always to divide by the coefficient. Divide by 3 on both sides, and you get x equals negative 3. Bada bing, bada boom. Alright, so let's look at a practice problem. Solve for x, right? I have an x on this side, I have an x on this side. So again, I need to move one of these to get them on the same side. If it's me, I'm always going to work with the smaller number. Negative 8 is smaller than a positive 20. So I'm going to move the negative 8. And again, how do I move something in math? I'm going to use the inverse operation. So right now it's a negative 8, which means the inverse of that is to add 8x to both sides. When you do, that cancels out, and you're left with positive 14 over here. So 14. On the other side, you're going to combine these, and you have 20x plus 8x, which equals 28x. And again, 28x, when I write something side by side, it means they're multiplied together. So 28x means it's 28 times x. Therefore, the inverse of times would be to divide. So we're dividing by the coefficient of 28 on both sides. When you divide 14 by 28, you get x equals 1/2. 14 divided by 28 is 0.5 or 1/2. So there's your answer. Let's see how we did, right? Okay, so here I am. I've got a negative 8x. I'm going to move it, so I'm going to add 8x to both sides. I get 14 equals 28x. The last step is to divide by 28, divide by the coefficient, or what is with the x. So I'm dividing by 28 on both sides, and I get x equals 1/2. Coach Sapp, you're a genius. Thank you, guys. All right, so now we have two special cases. We have two special cases. All right, what happens when I cancel out my variables? So in this example, I have a negative 5x plus 12 is equal to negative 5x. Well, when you move one of these negative 5x's, you're going to add it, right? So I have a negative 5x and I add it to this side. That cancels out. But when you have a negative 5x and you add the 5x to this side, it also cancels out. So here you have 12 equals 0 because it canceled out. It went away. There's nothing on this side. Well, 12 does not equal 0. Okay, so your two special cases when your variable cancels out, if the statement is true, that means that the solution is all real numbers. Okay, and we'll show you that in a second. If the statement is false, and what I mean by statement, I'll show you in a second. If the statement is false, it means there is no solution. So again, that's a true statement. It's all real numbers. If the statement is false, it's no solution. So let's go back to my example problem. Not that one, this one. Right? So my x is canceled out. Okay, and so here's my statement. My statement is 12 equals 0. Well, that is not a true statement. In no way, shape, or form does 12 equal 0. So if 12 does not equal 0, it's a false statement. Therefore, my answer is no solution. Let's look at another problem. So here are my two special cases. I've got 4x minus 7 is equal to negative 7 plus 4x. So again, I want to move the x to get them on the same side. So it's a positive 4x. When I move it, I'm going to subtract 4x on both sides. And again, these cancel out and these cancel out. So you have a negative 7 on the left, you have a negative 7 on the right. So my statement reads, is negative 7 equal to negative 7? Always. Always. Negative 7 is always equal to negative 7. So it's a true statement. Therefore, your answer is all real numbers. So what that means, guys, is you could plug in any number in place of this x value right here, and you're always going to get a true statement. No matter what value I plug in, you're always going to get a true statement. Just like negative 7 is always equal to negative 7, no matter what. So no matter what value I plug in, no matter what number I plug in, all real numbers, my statement is always true. Going to my no solution, there is no number that I could plug in place of x to make this statement true. 4 is never going to be equal to negative 3, no matter what I plug in for 8, because whatever I plug in for x, because whatever you plug in for x right here, you've got to plug in for x over here also. So this essentially is the same exact thing as this. Well, we're back to here. 4 does not ever equal negative 3. No matter if I plug in 1 for x or 100 for x. You get a 1, you plug in 1 here, you get 8. Guess what? You get 8 over here. So you're back to, is 4 equal to negative 3? It never is. If you plug in 100, you've got 800 over here. Guess what? You've got 800 right here also. So we're back to the same thing. Does 4 equal negative 3? It never does. So there is no number, no solution that I can plug in to make this a true equation. So my special cases, when my variable cancels out, you have two possible options: all real numbers or no solution. Now, an inequality is solved the exact same way as an equation. Right? An inequality is solved the exact same way as an equation, except one rule that equations don't have. If you multiply or divide both sides of your inequality by a negative number, you flip the inequality sign. So if you multiply or divide by a negative number, you flip the inequality sign. And what I mean by flip the inequality sign is you change it. If it was a greater than, you make it a less than. If it was a less than, you make it a greater than. If it was a less than or equal to, you make it a greater than or equal to. If it was a greater than or equal to, you make it a less than or equal to. Okay, so all you're doing is you're changing the sign. If it was less than, you make it greater than. If it was greater than, you make it less than. Alright, so what that looks like. I've got a negative 4x plus 3 is less than or equal to 15. So again, I want to isolate for the x. Okay, the reason I don't have to move the x here is because there are no like terms with the x. So let's go ahead and move this plus 3. The way I move something in math is inverse operations. It's a plus 3, so the inverse of that would be a negative 3, or to subtract 3. Do it on both sides. So you've got a negative 4x over here. You get 15 minus 3 over here, you get 12. Alright, this is a negative 4 times x. Again, inverse operations of times would be to divide. You guessed it, right? So I'm dividing by a negative 4 on both sides. Again, anytime you multiply or you divide by a negative number, you have got to flip the sign. So it was a less than or equal to sign. Notice in my answer it is a greater than or equal to. If there's a equal to bar underneath, it stays there. If there was not one, you can't put one in there. So it was a less than or equal to sign, it became a greater than or equal to sign. Why? Because I divided by a negative number. It'd be the same thing if I was multiplying by a negative number, guys. You flip the sign. That's it. Easy breezy. We're not learning anything new, guys. You've got it.